This is question 11 from the SACE Stage 2 Physics Course Companion from subtopic 3.4, the Standard Model. Here we have a pion and an antipion, both with a mass of 2.4883 times 10 to the power of minus 28 kilograms, annihilating to form two photons. We need to calculate the energy of the photons in mega electron volts and then the frequency and wavelength of those photons. Now, before we get too excited, I think we might just draw a picture of what's actually happening. So we have our pion and our antipion annihilating, forming two photons. Now, we know that since they both have the same mass, then essentially we have one of the pions having all the energy being converted into a photon, and similarly for the antipion, the other way around. So we have, both of those each are going to a photon. So if we use our mass-energy relationship for one of those masses, that'll be the same as the energy of one of the photons. So we'll just do the calculation like that. So here we have, for part A, we want to work out the energy in mega electron volts. We are using the relationship E equals delta mc squared. Here the mass is 2.4883 times 10 to the power of minus 28 kilograms times the speed of light, all squared. And if we substitute that into our calculator, we get 2.2395 times 10 to the power of minus 11 joules. We need to convert that into electron volts. The way we do this is by dividing by the charge of an electron. So 395 times 10 to the minus 11 divided by charge of an electron, 1.6 times 10 to the power of minus 19, which ends up being 1.3997 times 10 to the power of 8 electron volts. We want that to be in mega electron volts, so we need it to be times 10 to the power of 6, which means we move the decimal point 2 spots across. So it will be 139.97 mega electron volts. It seems like it's too many significant figures, so this will probably end up just being 140 mega electron volts. So that's not so bad. Part B, we need to work out the frequency and wavelength of a photon with this energy. We're using the relationship E equals HF, therefore F equals E on H, where H is Planck's constant. We have the energy from before, that was the 2.2395 times 10 to the power of minus 11, all over Planck's constant, 6.63 times 10 to the power of minus 34. Substitute that into the calculator, we get 3.38 times 10 to the power of 22 hertz. And finally, to work out the wavelength, we're just using the wave equation, V equals F lambda. Therefore, lambda equals V on F. V is the speed of light, 3 times 10 to the power of 8, all over our frequency, which we've just calculated. Substitute that into our calculator, and we get 8.88 times 10 to the minus 15 meters. And that's it. So these last two equations are fairly straightforward. They're calculations that we've done all through this subtopic. It should be very familiar. The first part of it is a little bit different. There's a lot of squares and things going on, but ultimately it's not really that difficult either. It's just remembering to do the conversions and everything correctly. Everything else is fairly straightforward. And there you have it.